So I'm Chetan Baru from SDSC. My collaborator in this is Vishu Nandigam. He's the co-PI on this project that I'll say a little bit more about. But he gave me the job of presenting it, so he gets to answer all the questions. In terms of the context of this, I think let me already answer the question of why UCSD. So as you'll hear, this is a project that's here because of SDSC. So because of the computational and storage and in general the cyber infrastructure capabilities that a center like SDSC provides is what brought the project here. Halfway through the presentation, I'm going to switch and then talk about how we might take a system like this and generalize it. I'm a computer scientist. I'm used to building tools that broad communities can use. So how do we take something like this that was built essentially for a community that's interested in topographic data and generalize it that we could maybe use it on campus for a lot of things. As you hear, all of these presentations that you heard until now today, and I suspect maybe all of the ones that you'll hear later, involve data in one way or the other. And so I think infrastructure that goes to support very heterogeneous and maybe in some cases large-scale data is going to be essential. And that's sort of the theme of this presentation. This project itself is about LIDAR data, which is a kind of remote sensing data that there are multiple kinds, and I know there are folks in this room who are actually experts at collecting and using this data, but maybe not all of you. There are multiple ways by which you can collect this data. Essentially, it's a laser instrument. You shine a laser, look for the return, and the return tells you something about the shape of the object that you have shown the light on. You could have tripod kinds of things, so you can have terrestrial scanning. You can put a laser device here and scan this room. You could put it in front of a cliff face and get the details of the cliff or a rock face, etc. You could put this on a plane and flight, and you get meter scale resolutions for detailed data, and you could put it on a satellite. If you put it on a plane and get LIDAR data, it sort of looks like this. It's topography of a particular region, and all my animation is gone. So, OK. So this will be quicker. Actually, what you could do is remove the green stuff, and you can see what's below the canopy. And that's how a geomorphologist might use it to look at large-scale earthquake features, et cetera. With the canopy, as you can see, you can tell the canopy height. You could use this for calculating, for example, biomass and things of that nature. So these would also, think of these as very large data sets and processing routines that are available on top of this data for you to do these different kinds of processing on the data. So what we have done here is built all of this infrastructure, nice colorful boxes. Down here are storage systems that store the data, and there's a variety of different data types. I'm not going to go into the details, but sort of the raw data that we get are called point clouds. The derived products are DEM elevation models, and there are all sorts of other data, imagery, for example. And on this side is the computing that goes on top of the data. And as you can see, some of the computing actually exploits machines that we have here at SDSC, for example, the Gordon system. And then on top of these are services that are provided. So these are processing routines. So nowadays, we call this a cloud, because the data is out there somewhere with the processing. And all you have to do is go through a web browser, invoke the computing, and get to the data products that you care about. So this is really the OpenTopography project. As was mentioned just now, go after what are national initiatives. This is a nationally funded resource. It's funded by the Earth Science Facilities Program. And it's actually a national collaboration. SDSC, we get to do all the infrastructure part, the cyber infrastructure. Ramon Arrowsmith at Arizona State is the sort of the science representative and the face to the community. And Chris Crosby at UNAVCO does the education and training and the user support of a facility like this. And there's an advisory committee. Once again, down here are resources that we use. Partners provide data to us. We are not collecting data. Somebody else is collecting data. This is important to understand that what OpenTopography is this service in the middle. Sometimes that's called the platform. So it's the platform as a service. The data comes from elsewhere. The processing routines may actually come from the community who contribute this into the facility. And the resources, some of them we own, but we also use SDSC resources. So there is actually a play nowadays to build these kinds of things, to build the platform that allows you to get to the data. That in and of itself has value and actually has a lot of importance. So what OpenTopography does today, you can call it a data warehouse. The concept of data warehouse is you have carefully gone through your data, carefully structured it, put it in these beautiful databases that are very efficient to access, and then you put routines on top of that to process it. There are standard services, and then you have fixed applications that use it. Whoa. OK, my animation is completely gone. So what you can't see behind this, which is actually the important part, is increasingly what's happening is there's a lot of data that's coming in. So you cannot pay the amount of effort for all of this data coming in to make it properly structured and put it into these archives. And also, there are data that are not as well-structured information that are also being thrown into this. They may not be in this case, LIDAR data. They may be related to elevation data. There may be other data sets. And this is what you heard today. There are so many different data sets that people have talked about that you can actually imagine a system essentially where you throw all this data together. A term that's emerged even in enterprise world is the notion of a data lake, or it's called an enterprise data hub, where you put in all of these kinds of data and then provide access to them. The access could be provided by applications that users develop. So there's a notion of you can think of it as an app store, okay? And then you can develop third-party applications that sit on top of this. You could also do social networking with this data. So these are two data sets. That's the Lake Tahoe LIDAR data, and that's the LIDAR data for the San Andreas Fault from north to south. And what you see here, where there's a lot of red, is where a lot of users are accessing that data set. So you know where people are accessing data. You know who is accessing data in your own area or next to you. You could do social networking, connect those kind of people together. If you know some data is being accessed a lot, you can cache it and make it fast access. So these are all the possibilities that you get. So here are some ideas for UCSD is to think of a data lake concept for all of our data. There's a lot of data that's produced here that can be integrated with other data. So this could be a service. There's no reason why you couldn't take the infrastructure that I just showed you and extend it to lots of other kinds of data. It's very generic kinds of infrastructure, and there's nothing essentially specific about it that has to do with topography other than the fact that the routines that operate on it know that it's topographic data. Similarly, we could be providing App Store for all of the kind of applications, not just what researchers are developing. Students might be developing this as part of class projects. These could get up there. You could have different gradations of data, one that's well curated versus one that's just ad hoc. You could do the same thing with processing routines. And finally, like I said, you could social network with the data. I apologize. I really use a lot of animation in my slides. And this is the Mac Windows problem. So, okay.
Well, that kept you on time. Thank you. So, question for Chaitan, Lisa.
The deep ocean is very much in need of that kind of data network gathering and distribution. Maybe the physical data are often more aggregated, but the biological data are so disparate around the world, and we desperately, to have any hope of managing, we need to pull it together.
Yeah, good comment. And I guess I'll add one comment on top of Lisa's, and that's what you're showing us is very exciting because the experts deal with the algorithmic layer for how to do things like manipulate quad trees to get at that pixel. And you're putting a layer on top of it. And this is on top of the Supercomputer Center providing co-location and all sorts of facilities for data storage and archiving. You know, I know my own laboratory co-locates all our computers at the Supercomputer Center now, and that means that my own servers are just a tip of the iceberg, and I can take advantage of these seamlessly. And that's available to any faculty here already. So this is a terrific paradigm that you're offering here.
Actually, I should mention that. In fact, it turns out that in any of these kind of things, there's the 80-20 rule. I mentioned that we have pre-computed data, the digital elevation models. 80% of the people who come to this facility just download the data that's already available. In other words, they trust the facility and they're happy with the product. The 20% are what we call the power users, and they want to come in and actually get the raw data and do processing. And that you'll see that kind of characteristics. In other words, with this, you actually make the use of the data greater because you provide these finished products and people just want to come and use it. Which is another aspect, by the way, of big data. The big data notion is that data may be collected by somebody for one particular purpose, but it may be used by somebody else for a completely different purpose. One of the quotes I didn't put here, we now have a guy from Electronic Arts, which is a gaming company that you might know about, who has suddenly discovered that they can use the LIDAR data from our side to create more realistic scenes in video games. So next time you see a teenage kid or preteen working on these things, it might be from LIDAR.
Great. Are there other questions? All right. Yeah, we're one of the very few campuses that has our very own supercomputer center that's a national facility located smack in the middle of the entire campus.
Yeah.
It's a pretty unique advantage. Yeah. All right, let's thank Chaitan.